diagnosis work? Because now we've just both said, well, it's one of those, you know it when you see it things. And something that is, to use a word we've used a million times on this podcast, so ineffable, how do you then train machines to help you identify it? Talk about closing some of those gaps and jumping over some of those hurdles, Dennis. How do you then employ the use of machine learning and AI to help us identify and diagnose this thing that very smart individuals sit here and go, well, it's hard to say, but we don't know enough, but we know it when we see it.
Yeah, no, that's a great point. In fact, clinicians who do routine diagnosis will say to me that they can hear which kids have autism as they walk from their office through the waiting room to the clinical evaluation room. And I believe it. What I always wanted to do was figure out how to quantify that and provide it to non-specialists. It's like, ultimately, when you think about AI in medicine, in a lot of cases, it's going to be scaling specialists. It's going to be scaling the intuitive specialist behaviors and abilities to the community settings, to dispersed settings, to lower socioeconomic settings, which is so important, right? To increase diversity and inclusion and everything else, which isn't happening at all today in the autism world, both for diagnostics and for therapeutics. Huge disparities there. So to answer your question, though, I think the one thing I just want to be clear for the audience is that AI is not anywhere near where it needs to be able to detect automatically autism in a video, right? Or in a sound. But we're getting there, ultimately. So the Cognoa system, the Canvas DX system, does require human inputs and human observations. We've just figured out how to minimize and optimize the amount of human input and observations that are required. And those are essentially vectors that get put together into the equation, essentially, and that those vectors combined enable the machine learning system to run to produce scores. But the cool thing also about this is that as we receive those measures, in particular, we receive those measures from independent observers operating in parallel. Independent inter-rater reliability becomes possible, something that's not possible today. And we're getting labels essentially generated on time sequence video data that become, obviously powerful potentials for future AI model development. You indicated earlier that AI is only as smart as the data we give it. And right now we don't have a lot of data on these kinds of individuals. But the more we can succeed with like a system such as Canvas DX, operationally in the future, there's going to be an opportunity to build smarter models that will obviate the need increasingly, although probably never entirely, for human input in this equation. And that's good because scaling continues to be, a thing we have to worry about. Scaling, and of course, then you're gonna the issues of security and privacy and AI, performance drift and all these things we should be talking about, and we're very mindful of. But I just wanted to at least say that for now, just to give you an idea of how things work.